Okay, guys, let's have a look at question 8 then. The circle C has centre A and equation here. X squared plus y squared minus 2x plus 6y minus 15 equals 0. Write down the coordinates of the centre A then. And then part 2, that was part 1. Part 2, the point P has coordinates 4, 7 and lies on C, on the circle. Find the equation of the tangent to C at P. Right? So this point lies on the circle, and they want the tangent to the circle at that point P. Okay, that's quite clear for part A. Let's go to the notes then, which I've already written down the question. Here's the equation for the circle, and that equals 0. And then we're asked to find the coordinates of the centre A. So I've done a little sketch of a circle with centre A. Then we're told that the point P lies on the circle, which is 4 minus 7. And then we want the tangent, and that's part 2. This is part 1. And the tangent is part 2, equation of tangent. So let's have a go at that then, part 1. The first thing to do is probably to write this in a way that you can read off the centre easily. And half of minus 2x is x minus 1. So I put x minus 1 squared. Now, that's that and that taken care of when you expand that bracket. But when you do, you'll get a plus 1. So you need to take care of that by putting a minus 1 so it cancels out and just leaves these two terms when you expand this bracket. By the same token, the y squared plus 6y can be written as y plus 3 squared. But you'll see, you get when you expand this bracket, you'll get a y squared, you'll get a 6y, but you'll also get a 9. So if I put minus 9, that will cancel the 9 that comes out, and I'll just get these two. So that's those 4 terms written down here. Then the minus 15, and that equals 0. Okay? So, what have we got then? We've got x minus 1 squared plus y plus 3 squared, and then the minus 1 minus 9 minus 15 is minus 26, and I can write that over the other side as 26. This is the equation then in standard form of a circle, so we can read off. So centre is A, the coordinates will be 1, and this will be minus 3, wouldn't it? There's our circle, 1 minus 3, and that's part 1. And then part 2, well, we know A, so we know A, so I'm going to draw a bigger picture of it now. And I'm just drawing points here. It's just for illustrative purposes. Here's P. It doesn't matter where they are. And then I want this tangent here, which is at 90 degrees. So if I get this gradient, I'll be able to find that gradient, because the product of two gradients is minus 1. And then I know that gradient then. Once I know this one, I'll know that gradient, and I know it goes through that, and I can get the line. So the gradient here will be simply the increase in y. So it goes from minus 3 on the y value to minus 7. So that increases by minus 4. It's actually going down this line. So there's the increase in y. And the increase in x is 3. So the gradient equals minus 4/3. And that's a poor sketch now because the negative gradient, it doesn't matter, it was just for illustrative purposes. So m1 is minus 4/3. It would have helped actually to draw it more accurately. So m2, because they're products, since m1 times m2, better put this down, equals minus 1, m2 is equal to 3/4. So there's the gradient for m2. Now, what have we got? Y equals 3/4 x plus c. Mx plus c is the gradient in the straight line at P, which is 4 and minus 7. We see that. What have we got? Well, y is minus 7. That equals 3/4 of x, which is 4 plus c. So the 4's cancel. 3 comes over, c is minus 10. So that implies then y equals 3/4 x minus 10. That's the equation of the line at P. Line at P, and that's tangent, isn't it? the tangent line at P. So that's fine. Okay, good. That's 8 part A done then. Great, I think everything's okay there. This diagram could have been done better, but it was only for illustrative purposes for us to see what the gradients were. But the algebra, all the algebra is fine, I think. We've come out with our tangent line at P for part 2. So I better put part 2 here that we're working out. Okay then, good. Let's go on to the next part. Great.